very good morning, students. Today we'll be dealing with the general character of the ocean currents. Seas and oceans are dynamic ecosystems. Oceans are very vast bodies of water representing a major portion of the hydrosphere. Air-sea interface is an interactive interface. The wind blowing on the surface of the ocean has the greatest effect on the movement of the surface water. The sunlight falling on the ocean surface has a very significant impact on the temperature of the seawater. These factors induce the oceanic water masses to move and circulate. Both vertical and horizontal movement of both surface and deep water masses happen in the world's oceans. They are called as the ocean currents. The ocean water circulation is an important aspect of study in oceanography. We need to understand the ocean currents, waves and tides and their distribution on the globe. In this lesson is focused to learn about the ocean water currents. After this lesson, you will be able to understand the ocean currents, causes of the ocean currents, types of currents. Measurement of the ocean currents. When Benjamin Franklin was a postmaster in American colonies, in his time, all the letters and the postal packages were transported across the continents through oceans by boats. He heard some complaints in 1769 that the mail boat from North America, which went to Europe, reached much faster than the mail boat which was traveling in the opposite direction. The boats traveling from Europe to North America took weeks longer than the mail boats which were heading towards the opposite direction. He took these complaints very seriously. Since he was the postmaster, the mail delivery was very important to him. Franklin wanted to figure out what was going on with the delayed mail delivery system. Benjamin Franklin crossed the Atlantic several times by boat. He took the temperature measurements and making other observations of the ocean. He discovered that an ocean current was the reason behind the delay. Boats going towards Europe were speeded up by the prevailing current of that region. The boats that were going towards the North America were slowed down by the oceanic current flowing in the opposite direction. He called that the oceanic current or as the Gulf Stream. First map of the currents. The map that was made by Benjamin Franklin about the Gulf Stream in 1770 was the first map ever made of this ocean current. Mapping this current's path was very helpful for all the sailors. Franklin noticed many features that made the Gulf Stream water different from the surrounding ocean. One of the most characteristic features of the Gulf Stream was the difference in the temperature. The knot, pronounced as knot, is a unit of speed used in the oceanographic studies. Knots in nautical miles. 1 knot is equal to 1 nautical mile per hour or 1.852 km per hour. 1 knot speed is equal to 0.5144 meter per second. The abbreviation knot is preferred by International Hydrographic Organization, which includes every major seafaring nation. Measurements of the ocean currents are carried out by a variety of methods. One popular way to measure ocean currents is to determine the water's velocity at one fixed place in the ocean. This type of measurement is called Eulerian, in honor of the Swiss mathematician Leonhard Euler. This is accomplished by using the electromechanical current meters. Current meters measure the velocity of water at a single depth. The modern acoustic Doppler current profiler also can provide a profile of velocity of water flow along with the details of the water depth. In addition, current measurements are done using radar-based equipment. Current measurements. Another direct way to measure the ocean currents is by tagging a lighter material which floats or using colored ice. The near surface ocean currents are measured by so-called drifters. Drifters are buoys which ride at the ocean surface and are drugs at some depth to negate the direct effects of the wind. Tracking this drifter by satellite, radar, radio, sound, etc. We'll give a description of the ocean current, Sevedrup. Sevedrup is the basic unit of volume of transport used in physical oceanography. It is equal to 1 million cubic meters of water flowing per second. Ocean water currents. Currents are large-scale water movements occurring everywhere in the world. They normally move in certain specific directions. It is due to the circulation the atmospheric moisture is replenished in the atmosphere of the earth. Because ocean currents circulate water worldwide, they have a significant impact on the movement of energy and moisture between the oceans and the atmosphere. As a result, they are important to the world's weather. Forcing mechanisms. Currents are referred according to their forcing mechanisms. They may be either wind-driven or thermohaline. Many marine life rely on these currents to move from one location to another, whether it is for breeding or for food or for adaptation purposes. Today, ocean currents are also gaining importance due to the possibility of harnessing alternative energy sources. Because the ocean water is dense, it carries enormous amount of energy that could possibly be captured and co-invented into a usable form through the use of turbine generators. Causes of the ocean currents. The unequal heating of the Earth's surface and the movement of the water masses along the surface by the winds are responsible for the development of the currents. Currents are the reflections of the ocean water circulations. The factors responsible for the oceanic water masses to circulate are wind, salinity, density, temperature, ocean morphology and relief, and the Earth's rotation. The mechanisms responsible for creation of ocean currents are global movement of winds and Coriolis force, Ekman flow, temperature and density differences, geostrophic influences, pressure gradient, upwelling, and the configuration of the ocean flows. Properties. An ocean current is a continuous directed movement of seawater generated by the forces acting upon it. Ocean currents can flow for great distances and together they create the great flow of the water masses. Surface ocean currents can be very large. Surface ocean currents flow in a regular pattern, but they are not all the same. Some currents are deep and narrow, other currents are shallow and wide. Currents are often affected by the shape of the ocean flow. Some move quickly while others move more slowly. A current can also change somewhat in depth and speed over time. Ocean currents show typical flow patterns. Major ocean currents. Currents are of two general categories as surface water currents and the deep water currents. In addition, there are specific names given to the currents which are distributed at different parts of the globe. They are the equatorial currents, boundary currents, circumpolar currents. In addition to these, there are some terminologies used to denote the ocean currents. They are periodic currents, seasonal currents, coastal currents, longshore currents, offshore currents, inshore currents, and the drift currents. Surface winds. The water mass present at the ocean surface is moved primarily by the winds. Winds blow in certain directions and patterns. Oceanic water masses are also moved due to the Earth's rotation and by the Coriolis effect. Wind-driven circulation is the large-scale oceanic circulation that results from the actions of the wind. There are two components involved such as directly driven Ekman component and an indirect component, the geostrophic balance with the pressure systems. The speed of the surface currents is greatest closer to the ocean surface and decreases at about 100 meters below the surface. This makes up to 10% of the oceanic water masses. Because surface currents travel over long distances, the Coriolis force also plays a role in their movement and deflects them, further aiding in the creation of their circular pattern. Finally, Gravity plays a role in the movement of surface currents because the top of the oceans is uneven. Deep water currents. Deep water currents are another category of the ocean currents. They are also called as the thermohaline circulation. They are found below 400 meters and make up about 90% of the ocean. Like surface currents, gravity plays a dominant role in the creation of deep water currents. This is mainly caused by the density differences in the oceanic water masses. Kinds of currents. The oceanic currents are classified according to the force that makes them to flow. The various kinds of currents include the tidal currents, density currents, wind-driven currents, gyres, rip currents, and cold surface currents. Tidal currents. Tidal currents, as their name suggests, are generated by the tides. Tides are essentially long, slow waves created by the gravitational pull of moon and to a lesser degree the sun on the Earth's surface. Since the moon is so much closer to the earth than the sun, its pull has more influence on the tides. The tidal currents are caused by flooding of the water flowing from one location to another. Normally, the flow speed of these tidal currents is small, typically less than 0.5 meter per second. Tidal currents flow closer to the coast. Density currents. A less dense substance will always lie above a more dense substance. When you have water of two different densities meeting, the lower density, less dense water will move on top of the higher density, more dense water. The different densities actually cause the water to move, forming a density current. In the oceans, the deep bottom currents are colder and saltier than the surface currents. Density differences are a function of temperature and salinity. Role of gravity. Density currents are driven by gravity. Density differences in a fluid in a gravitational field leads to pressure differences that drives the flow. The density currents are created due to variation in the density of water. The more dense saline water normally starts flowing under the less dense water. This is called a density current. It is mainly driven by difference in densities between the two water masses. These flows are a few centimeters per second or less. Wind-driven currents. The wind-driven currents are the strongest currents in the world. As the name implies, they are mainly driven by the winds. The wind can cause surface flow of nominally 2.5% of the wind speed, which is 10 meter per second wind speed, may generate less than or equal to 25 centimeters per second of the surface flow. This is known as the wind drift. A current can also change its courses somewhat in the depth and speed over time. Winds are able to move the top 400 meters of the ocean, creating surface ocean currents. Surface currents are mostly caused by the wind because it creates friction as it moves over the water. This friction then forces the water to move in a spiral pattern, creating gyres. In the northern hemisphere, gyres move clockwise, and in southern, they spin counterclockwise. Gyres. Gyres are yet another type of the currents in the oceans. These are circular, large-scale ocean flow patterns. They result from the wind forcing, buoyancy forcing, and the Coriolis acceleration. Since the Coriolis acceleration changes with latitude, gyre circulations are not symmetric and the flow on the western boundaries is stronger. Gyres flow in clockwise direction in the oceans of the northern hemisphere and in counterclockwise direction in the southern hemisphere. This happens mainly because of the Coriolis effect creating surface ocean currents. Near the Earth's poles, gyres tend to flow in the opposite direction. Some of the ocean currents move quickly while others move slowly. Types of gyres. Gyres are of various kinds such as subtropical gyres, subpolar gyres, recirculation gyres. Subtropical gyres are found in all the world's oceans at mid-latitudes. Subpolar gyres have opposite circulation and are found poleward of the subtropical gyres. Recirculation gyres are flows associated with major ocean currents and consist of water that recirculates in a closed pattern around most of the ocean basin. large-scale recirculation gyres are associated with fast western boundary currents, rip currents. Rip currents are seen closer to the beaches when the waves tend to carry water towards the coast. Changes in the bottom topography, for example the sandbanks, can cause water to be moved towards the beach without allowing the water to return to the deeper sea. The flow of the water going back towards the deeper sea then occurs quite suddenly in the form of a narrow, less than 5 meter wide current moving quite fast, up to 2 meter per second. These are called as the rip currents. Cold surface currents. The next type of the currents are the cold surface currents. These currents come from polar and temperate latitudes and they tend to flow towards the equator. Like warm surface currents, the cold surface currents are driven mainly by the atmospheric forces and are influenced by the Earth's rotation. Thermohaline circulation. Warm water holds less salt than cold water, so it is less dense. When it is less dense, it rises towards the surface of the oceans. When it is cold, it becomes denser and the salt-laden water sinks down below. As the warm water rises up, the cold water is forced to move away through upwelling and fill the void left by the warm waters. By contrast, when the cold water rises, it too leaves a void and the rising warm water is then forced to fill up the gap, though through downwelling. These are called as the thermohaline circulation. This thermohaline circulation is induced by differences in temperature and salinity. Thermohaline circulation is known as the global conveyor belt because its circulation of warm and cold water acts as a submarine river and moves the water masses throughout the oceans. This is one of the very unique phenomena of the oceanic water masses. Ekman transport. Surface winds and ocean currents are intimately related to each other. Winds normally blow across water and drag on the surface. This sets a thin layer of water to move and tries to drag on the water present below. This process continues downward and the transfer the momentum continuously downwards towards the deep layers. The energy is lost in the process. As a result, the current speed decreases with depth. Since Earth rotates, the movements of the surface waters are deflected to the right of the wind in the northern hemisphere. The change in the current direction and the speed with increasing depth forms a spiral. This is called as the Ekman spiral. It is named after the pioneering work of the Swedish oceanographer V.W. Ekman, who laid the foundation for dynamical theories of wind-driven ocean circulation. Upwelling. These are places in the ocean where water from the deep sea travels up to the surface. These are called as areas of upwelling. Coastal upwelling is usually induced by Ekman transport. The other significant component of large-scale ocean circulation flow is wind-driven and is known as Ekman flow. Upwelling is a mechanism which brings the cold, nutrient-rich water from the depths up to the surface. Earth's rotation and strong seasonal winds push the surface water away from some coasts, so water rises on the edges of the continents to replace it. Upwelling also happens as a part of El Niño events in the Pacific Ocean off the coast of Ecuador and Peru. This has an impact on the weather, changing the pattern of the precipitation in many areas of the world. Downwelling. Downwelling is the opposite of the upwelling, surface waters pushing down into the deeper areas of the ocean. This happens when the winds cause Ekman transport to push water toward a coast and then deeper in the ocean. Geostrophic currents. Geostrophic currents are controlled by a balance between a pressure gradient force and the Coriolis deflection. In addition to these, the sea floor topography and the shape of the ocean's basins have a greater impact on the surface and the deep water currents. These conditions may restrict the flow between the basin areas where water can move and funnel it into another basin area. Surface ocean currents carry heat from place to place in the Earth's system. This affects the regional climatic conditions as well. Ocean eddies and rings. Eddies with horizontal diameters varying in size from 50 to 150 kilometers have their own pattern of surface currents. They form rings due to the western boundary currents like the Gulf streams. At the equator and along the ocean boundaries, shallow undercurrents exist, flowing in a direction counter to that at the surface. These types of currents may affect the operation of submarines or trawlers. One good example is the equatorial undercurrent. Currents are also important for marine life because they transport most of the marine creatures all around the world. Currents affect the water temperatures in the marine ecosystems. Currents play a major role in controlling the climate. Currents play an important role in the navigation of the ships. Knowledge of the ocean currents is essential to carry out the movement of the ships, reduction in their shipping costs, and fuel consumption. Knowledge of surface ocean currents is essential in reducing costs of shipping since traveling with them reduces the fuel costs.